Hi guys. So today we're going to be solving more exponential and logarithm equations. They're going to be a little more complicated equations than we've been doing the last lesson. And today is March 25th. So 325. Okay. And then logarithm properties. Okay. So some of this we've already gone over. In fact, all of it we've already gone over. All right. But I want to talk about why. Okay. So for positive numbers x, y, and a not equaling to 1, and any real number r, these statements are all true. Okay. Now let's talk about this first one, right? Log base a of 1 is equal to 0. Why? Why? You should be able to explain why. Okay. So the why is this: log base a and of 1. Now, we want this to be base a, right? So there's a way to write 1 base a. It would be a to the 0, okay? So that's why this is equal to 0, okay? Because log base a of a to the 0 would equal 0, okay? Why is this one, why is log of base a of a equal to 1? Similar rationale, okay? Similar reasonings. Log base a of a, and what is this right here? Well, this is the power of 1, right? That's why this one's equal to 1. Okay, so those are going to be those are important that you could explain to somebody why it's that value, why log base a of 1 is equal to 0, okay, or log base a of a is equal to 1. All right, so here's the other one. When we're taking two logarithms that have the same base, okay, we can rewrite that as a single logarithm with the same base. And these two arguments, these are called arguments, what we're taking the log of, x here and y here, we can rewrite that as a new argument of x times y. So if you're adding two logarithms, then what you can do is multiply the two things that you're taking the log of and write it as a single logarithm. If you're subtracting two logarithms, okay, you can rewrite that as the quotient of this argument over this argument. So x over y. And then if you have log base a of x to the r, we can bring that power of r, down in front and multiply by it. And these were all discussed and shown when we did those logarithm properties. Okay, let's go to example 1. All right, for example 1, what I want us to be able to do is solve 3 times e to the negative 10x minus 3 power plus 6 is equal to 102. So what we want to do is we want to get e to the power, this base and exponent, by itself first. So the first thing we would want to do is, what's the easiest thing to do, is to subtract 6 from both sides. So that would give us 3 times e to the negative 10x minus 3 is equal to, and then 102 minus 6 would be 96. And then the next thing we want to do this multiplying by 3, right? Because this exponent is only attached to the e. It's not with the 3. So that automatically means we're multiplying by 3. So how do we undo multiplying by 3? Divide both sides by 3, okay? So if we divide this side by 3, we're going to wind up with e to the negative 10x minus 3 is equal to, and then 96 divided by 3, 96 divided by 3 would be 32. All right, so now we have to undo this exponential, right? We want to undo this, okay? So a couple ways we could do this. We could actually do this with any logarithm, and then using that power, if we take like log base 10 of both sides, we could bring that power down in front, okay? Now, because this is base e, I'm going to want to use natural log and use the inverse properties, okay? So when it's base e, let's definitely use the natural log, okay? So natural log of e to the negative 10x minus 3, so I'm taking the natural log of both sides, is equivalent to the natural log of 32. Okay, what the base right here, this logarithm, remember, is base e again, right? So the natural log of base e of e to the negative 10x minus 3, well, it's going to undo. It's the inverse properties that we're using here. So this becomes negative 10x minus 3 is equal to the natural log of 32. And I'm putting parentheses around the 32, but you wouldn't have to, okay? And then the next thing we need to do is start getting this x by itself, okay? So the easiest thing to do is to add 3 to both sides. So then we have negative 10x is equal to the natural log of 32. And then we would have to add 3. To get rid of the minus 3 on this side, we'd have to add 3 to both sides. And then now we're multiplying x by negative 10. So the next step is divide by negative 10. So x would equal, and I'm going to slide it up a little bit, guys. So x would equal the natural log of 32 plus 3 all over negative 10. Okay, and then we could put that into our calculator and get an approximate answer. All right, so putting this into our calculator, we'd press alpha and then x to get the fraction bar, and then natural log. And notice it starts a parentheses, so we're going to close it, 32, and then close the parenthesis, and then plus 3, and then divide that. So we're going to put that over negative 10 and press enter, and we get negative 0.6465. So this fourth decimal place 5 right here means we're going to need to round this up excuse me, round this up to 7. Okay, now I'm actually okay if you write negative 0.646 and you just truncate. Okay, so I'm okay with either of those answers. Okay. All right, if you go to Desmos, okay, you can calculate this value also we go to the expression window right here. I have extended this a little bit longer on my computer, and you can just grab this one side and just make it bigger or smaller. Okay, I'm trying to get the font to be bigger, font size. I haven't figured out how to do that yet. So we'd want to go down here to the keyboard, okay, and then select functions. And then get over here to the miscellaneous because we want the natural log function. So natural log of 32. So type in 32. Close the parenthesis. And then we want to add 3. And then if I press divide, I want to show you something that would be, the calculator can only do the calculation exactly what you tell it to do. So it will do it exactly the way you type it in. So if you press divide right now, okay, notice what happens. It's going to make the denominator be under 3. We actually want the denominator to be under everything, right? So what we need to do is go back and we need to use parentheses because we want to tell the calculator that I want the natural log of 32 plus 3 to be the numerator. So I'm going to open a parenthesis there, and then after the 3, I'm going to close the parenthesis. And actually, I take that back. I'm going to have to delete a little bit before we do this. Okay. So then plus 3, and then close the parenthesis. And then outside of the parenthesis there, now you divide. And then that puts the natural log of 32 plus 3 as your numerator like it's supposed to be. And then we'll type in negative 10. And we get the same answer we did with the graphing calculator. So negative 0.6465. And that 5 will cause the 6 to round up, or you can truncate. Okay? Okay, back to our problem. That would tell us that x is about negative 0.647. Or you could also have negative 0.646 if you truncate. Okay, so either one of those are acceptable. You don't have to have both, just one or the other. Okay, and now let's go on to the next example, guys. All right, guys, for example 2, we're going to be solving 8 minus 5 log base 7 of 5x minus 3 is equal to 3. This 5x minus 3 is called the argument of the logarithm. Okay, that's what we're taking the log of. And this argument, okay, for logarithms, it can't be 0 and it can't be negative. So this 5x minus 3 is going to have to be a positive value. Okay, so there's restrictions on these. Okay, so whenever you solve a logarithm equation, you got to worry about maybe getting extra solutions, because we're going to convert this from a logarithm equation to a different form of an equation. So either it's going to be a linear equation or a quadratic. Okay, so we're going to need to check our answers at the end. So every time you get a logarithm equation, we should be checking our answers. Okay. All right, so to solve this, okay, I'm going to point something out. It's easy to fall into this mistake, and we know how to do 8 minus 5, so we write a 3 here, right? So that can be a mistake. That's something I don't want you to do, because that wouldn't be correct, because you wouldn't be following order of operation, because before you do the subtraction, you'd have to multiply. And we can't actually multiply 5 times log, so you can't do the subtraction 8 minus 5. Okay, so the very first thing we want to do is we want to get this logarithm by itself. So log base 7 of 5x minus 3, we want to isolate that. We want to get it by itself. So the easiest way is to just remove this 8. So subtract 8 from both sides. So if we subtract 8, we'd wind up with negative 5 log base 7 of 5x minus 3 is equal to, and then this 3 right here, we're taking 8 away, right? So 3 minus 8 would be negative 5. All right. And now we still don't have the log base 7 of 5x minus 3 by itself. We need to undo this multiplying by negative 5. So how do we undo multiplying by negative 5? Yeah, divide both sides by negative 5. All right. So if we divide both sides by negative 5, we would wind up with log base 7 of 5x minus 3 is equal to, and then negative 5 divided by negative 5 would be 1. All right, so now, okay, what we want to do is we want to use the inverse properties. So how can we undo log base 7? We're going to exponentiate with base 7. So this is going to be the power, and this is going to be a power, okay? So you can't just put a 7 right here, okay? You need to rewrite a whole new line for this. Okay, so 7 raised to the log base 7 of 5x minus 3 is equal. So the reason you can't put a 7 here and just attach it is the equals is in the wrong spot, okay? The equals needs to be this exponential is equal to this exponential. So this would be 7 to the first power. Okay, 7 raised to the log base 7, they are going to undo each other, right? Okay, so you're going to be left with 5x minus 3. So 5x minus 3 is equal to 7 to the first, which would be 7. All right, so now what happened is we started out with a logarithm equation, okay? And we wound up with a linear equation. So we've converted this logarithm equation to a linear equation that's really easy. I mean, this is a math 1 problem, okay? Or even not even a math 1. It's actually an 8th grade math problem, okay? So what we need to do next is solve this one. So what happens is there's restrictions on this logarithm. Like this has to be positive. It can't be 0 and it can't be negative. But here, when we plug it in here, this could be anything. So that's why we got to check our answers when we're all done, okay? So the next thing we're going to do is we're going to add 3 to both sides, and that would give us 5x is equal to 10. And then we need to divide both sides by 5, and x would equal 2. Okay, now let's take a look. Does that cause problems? Does that make will this make it be true? Okay, so let's come back over here and we're going to do a check. Okay, and we're going to check, does x equal 2 work? Okay, so we have 8 minus 5 log base 7 of 5 times the 2 minus 3. Does that equal 3, right? And we want to show that this works, okay? So this is 8 minus 5 log base 7 of, and let's try to do this in our head. What's 5 times 2? That would be 10. And then 10 minus 3, that would be 7, right? Is equal to 3 in question mark. All right. And then, okay, so then this would be 8 minus 5. And then log base 7 of 7, well, that would be log base 7 of 7 to the first, right? Is equal to 3. So that means this logarithm right here, this part right here is 1. So this makes 8 minus 5 times 1, because log base 7 of 7 to the first is 1, is equal to 3. Well, that would be 8 minus 5, right? 8 minus 5, and that's equal to 3. And that means 3 is equal to 3. So what does that mean? That means this works, right? And so x equals 2 is our answer. We could box it. Okay, and that's how we're going to do example number 2. All right, guys? Okay, for example 3, we want to solve log base 6 of x plus log base 6 of x plus 9 is equal to 2. All right, so what we want to do is we want to exponentiate, but we can't do it yet because we need to write this as a single logarithm, and we can using the properties of logarithms, right? So if we take the log of two things that we're adding and the bases are the same, then we can multiply the x along with the x plus 9 together, right? So we're going to rewrite this as log base 6 of x times the quantity x plus 9. So I need to close the parentheses, and that's equal to 2. And that condensed to one logarithm now, right? Okay, so now I'm going to multiply this x times x plus 9. So this becomes log base 6 of x squared plus 9x is equal to 2. So now, because we have a logarithm equation, okay, and I should have said this before, okay, we're going to need to check our answers because these are logs, right? It's a logarithm equation, and we're going to need to check our answers because our answers may not work, okay? All right, so at this point is we want to undo this log base 6. Well, we can do that by exponentiating with base 6 as long as I do it the same thing to both sides. So this becomes 6 raised to the log base 6 of x squared plus 9x, and that's going to be equivalent to 6 squared, okay? All right, so 6 raised to the log base 6. These are going to undo each other, and you're going to be left with x squared plus 9x. So x squared plus 9x, and that's going to be equal to 6 squared, which is 36. Okay, so now you look at this equation. Okay, so now how do I solve this equation? How do I attack this equation and solve it? Okay, so you notice that there's an x squared term, there's an x, and there's a constant. Okay, that's a quadratic when that happens. So what do we have available? Well, depending on what situation we have, you could use square roots, or you could factor, or could you even use a quadratic formula? Okay, now I would try not to use the quadratic formula. I try to do everything else besides that because that's kind of the last two ditch effort to solve it. Okay. But what we want to do is we want to move the 36 over. Okay. And we're going to want to try to factor this. Now, why do I want to try factoring? It's because I have an x squared and an x term. If I just had the x squared term, then I'd want to use square roots. Okay. And that was all covered in last semester. Okay. All right. So I want to move the 36 over. So I'm going to have to subtract 36 from both sides. And that would give me x squared plus 9x minus 36 is equal to 0. All right, and now to factor this, we need to think of, okay, two numbers whose product is negative 36 and the same two numbers whose sum is 9, okay? And because the product is negative, I know one of them has to be positive and one of them has to be negative. And because the sum is positive, the bigger of these two numbers have to be positive. So if you think about 12 times 3 is 36. And if the 3 was negative, 12 times negative 3 would give you negative 36. And 12 plus negative 3 would give you positive 9. Okay, so there we go. That's what we're going to use to factor this. This can be rewritten as x plus 12 times x minus 3 is equal to 0, okay? Now what we want to use is the zero product property, okay? So the 0, I'm going to slide this up just a little bit more, okay? So the only way for a product to equal 0 is if one of the two things that you're multiplying together, in this case x plus 12 and x minus 3, one of those two things must be 0 also, okay? So either x plus 12 equals 0 or x minus 3 is equal to 0, which would give us x is equal to negative 12, and over here, x would equal 3. Now, do both of these work? Okay. All right, so we go back. I'm going to slide this up a little bit. Okay, we need to check. So we're going to check x equals negative 12. Okay, so this would be log base 6 of negative 12 plus log base 6 of negative 12 plus 9. Does that equal 2? Okay, so automatically, well, let me rewrite this. This would be log base 6 of negative 12 plus log base 6 of negative 3. Okay, so automatically, this isn't going to work. And here's why. We're trying to take the log of log base 6 of negative 12. This number right here has to be a positive number in order to take any logarithm, okay? So this must be positive. Okay, so it can't be 0 and it can't be negative. And then same thing here, okay? This must be positive. So automatically, this can't happen. If you try to put this into your calculator, it will give you an error because you can't take the log of a negative value. It's part of the domain that we're going to be talking about in the next couple of days. And we've actually talked about it earlier too, okay? So right here, it can't be negative 12. That means this one, this negative 12, okay? And I'm going to slide it up so you can see it. Okay, I've circled the negative x equals negative 12. That can't be it, so cross it out, okay? That can't be one of our answers. Okay, how about x equals 3? So I need to check that one, right? Will that one work? Okay, so going to my blue pen. I'm trying to move this slow because I know it gets kind of crazy if I move it too fast for you guys on the video. All right, so let's check x equals 3. Okay, so that would be log base 6 of 3 plus log base 6 of 3 plus 9, right? And that's equal to 2. And then this would be log base 6 of 3 plus log base 6 of 12. Does that equal 2? I'm going to put a question mark here. If you left off the question mark, it'd be okay. All right, and so we have log base 6 of 3 plus log base 6 of 12. Okay, we can rewrite that as a single logarithm. So that'd be log base 6 of 3 times 12, and 3 times 12 is 36. Okay, and okay, so to figure this out, okay, remember we can rewrite this 36 as 6 squared, right? So this becomes log base 6 of 6 squared, and we know this is 2. So 2 is equal to 2. This is a true statement. Let me slide it up. I just realized I came off the screen a little bit. So that's a true statement. So we got 2 answers because those were answers to this quadratic, right? So we converted, let me zoom out a little bit. Okay, so what we did is we converted a logarithm equation to a quadratic, and then we solved the quadratic. So these are 2 answers to this quadratic equation, all right? But because they came from a logarithm equation, okay, one of them didn't work in the logarithm part of it, okay? All right, so the only answer is this one, x equals 3. So we want to box that one. Okay, all right, and that's example 3. For example 4, we want to solve log base 2 of x minus log base 2 of x minus 5 is equal to 5. Okay, so we can rewrite this as a single logarithm because we're subtracting, and it would be the logarithm base 2 of x over x minus 5. So we're going to write that. So log base 2 of x over x minus 5, and that's equal to 5. And now we have it written as a single logarithm, which is going to allow us to exponentiate, okay? And we're going to want to exponentiate with base 2. So this would be 2 raised to the log base 2 of x over x minus 5 is equal to 2 to the 5th power. 2 raised to the log base 2, it's going to undo, all right? And then we're going to be left with x over x minus 5 is equal to 2 to the 5th power, and 2 to the 5th power would be 32. All right. And now, okay, originally we started with a logarithm equation, right? So there's going to be, there can be some problems with this, okay? Because remember, again, we have to be able to take the log of a positive value. This has to be positive. So the x has to be positive, and the x minus 5 also has to be positive, okay? And we've converted it to this type of equation. This is actually a rational equation that we learned how to solve 2 units ago, okay? So what we want to do is clear out this fraction right here, x minus 5, okay? So I'm going to write, I want to multiply this side by x minus 5. And I want to multiply this side by x minus 5. And I've talked a lot about this. I just wrote it incorrectly, right? Because what does this mean? Well, really what this means is I'm only multiplying by 5. And over on this side, I'm multiplying by x. So how do I show that I need to multiply by x minus 5 both sides? I must use parentheses, okay? All right, so now this x minus 5 cancels with this x minus 5 and makes just x on the left-hand side. And then this side would be 32 times x minus 5. And then we're going to distribute the 32. So that makes x is equal to 32x minus, and then 32 times 5 is 160. All right, and then we're going to subtract 32x from both sides. And this would be 1x minus 32x would give me negative 31x is equal to negative 160. And I'm going to divide both sides by negative 31. And that would give me an answer of 160 over 31. Okay. All right. And then we could put that into our calculator. All right. And if we take 160 and divide by 31, we get 5.161. Okay. But the good question is this an answer? Does this work? Does this answer solves this equation that we translated it into or converted it into, but does it solve the original one? So we have to go back, and then we need to put in 160 over 31. You don't want to put this because this is a rounded value, okay? So we're going to check, okay? X is equal to 160 over 31, okay? So this would be log base 2 of 160 over 31 minus log base 2 of 160 over 31 minus the 5. Does that equal 5? Okay. So I'm going to hold off. We can't do anything really with this. That's a complicated number right now. Okay. So this would be log base 32. Log base 32. Log base 2 of 160 over 31. Okay. Minus log base 2 of, okay, so we need to get a common denominator here of 31. So I need to multiply this 5 by 31 over 31. Okay. And that would give me 160 over 31 minus, and if I multiply by 31 over 31, that would give me 155 over 31. Does that equal 5? So log base 2 of 160 over 31 minus, and this would be log base 2 of, and then this would becomes 5 over 31. And does that equal 5? Okay, so I'm subtracting these two logarithms. Well, what's the property? I can take this logarithm, log of this 160 over 31 over 5 over 31, okay? So this becomes a single logarithm, log base 2 of, and this is 160 over 31, and this would be 5 over 31. Okay, so start a parenthesis here. This is a really ugly logarithm, okay? All right, so what do you notice here? Oh, complex fraction. Yeah, complex fractions, okay? So how do I clear out a denominator of 31 for both of them? Well, I'm gonna multiply by 31 over 31, right? I'm gonna close the parenthesis now. And does this equal, question mark, 5? Okay, so what happens when we do this? We get log base 2 of 160 over 5. Which does that equal 5? Well, what's 160 divided by 5? It's 32. So log base 2 of 32, does that equal 5? So that means log base 2, and 32 is a power of 2. So it could be rewritten as 2 to the 5th is equal to 5, question mark here. And then what does that mean? Well, these undo each other, right? So you have 5 equals 5, right? So this is a true statement, which means the answer we got actually works. It works in the logarithm and in this equation that we solved right here that we converted it to, okay? All right, let's go to example number 5. All right, for example 5, we want to solve log x minus log of the quantity x plus 3 is equal to log 12. Now, this isn't a typo. Remember, okay, there's no base that's being written, right? And that means something, okay? So it's not a typo that Mr. Mitchell just forgot to type in the base, right? No, it means it's a base 10 here when you don't see it, all right? So once again, we can condense this to one logarithm, all right? And it'd be the log of this x over x plus 3. So we're going to go right to that, all right? And again, we have a logarithm equation. So we're going to need to check our answers because we're going to convert this to another type of equation, okay? So this becomes log of x over x plus 3 is equal to log 12. And I'm going to put parentheses. You wouldn't have to put parentheses around the 12, okay? Now, we're going to want to exponentiate. Now, what base do we want to use? We want to use base 10. So this becomes 10 raised to the log of x over x plus 3 is equal to 10 raised to the log of 12. Okay, these are going to undo each other because there's a little base 10 that's not being written here. So this becomes x over x plus 3 is equal to, these are going to undo each other because there's a little 10 here that's not being written. There's a base 10 here. So that means this is equal to 12. We want to multiply next both sides by x plus 3. Okay. And so if I multiply this side by x plus 3, I would get x is equal to, if I multiply this side by x plus 3, I would get 12 times x plus 3. Is that the correct way of writing it? Answer is no. What do I need? I need parentheses. Okay, because that would have been just 12 times x, not 12 times the quantity x plus 3. Okay, so now I'm going to distribute the 12. So that's x is equal to 12x plus 12 times 3 is 36. Okay, subtract 12x from both sides. That would wind up being negative 11x is equal to 36. Divide both sides by negative 11. And I get x is equal to negative 36 over 11. Now, is that answer going to work? Okay, so we need to check, right? And we always want to check the exact answer, not the approximate, okay? And the approximate answer, I'm going to put right here. Okay, put that into our calculator. Negative 36 divided by 11. And you get negative 3.273. And I'm rounding, okay? So let's check. Does this work for negative 36/11? Okay, so x is equal to negative 36 11ths. Okay, so we have log of negative 36 over 11 minus log of negative 36 over 11 plus 3. Does that equal, question mark, log of 12? Okay, so right away, guess what? This isn't going to work. Why? Because right here, this needs to be a positive value for this to work, right? It needs to be positive. It can't be 0. It can't be negative. It has to be positive, okay? Must be positive. So this doesn't work out, right? If we use this number, we're going to take the log of it, and we can't take the log of a negative value. If you try putting this into your calculator, you will get an error, okay? So I'll show you my calculator. I'm just going to show you the screen right now, okay? So I'm going to press log button, okay? The log, it's right to the left of the number 7. So log of negative, and then my fraction bar, 36 over 11, and non-real answer, right? Okay, so it's not going to give us an answer, a real number answer. Okay, so that means this doesn't work, which means this was our only answer that we got, right? So put a circle around it, slash through it. No way, Jose, right? No, that's not going to work. So what does that mean? That was our only answer and it doesn't work. That means there's no solution to this equation. There's no x value that we can ever find that will make this true. Okay? All right. Now let's go on to the next example. All right. For example 6, we want to solve log base 2 of x squared minus 5 plus log base 2 of 9 is equal to log base 2 of 19. Because I'm adding here and the logarithms have the same base, that means I can multiply the two arguments together. Okay? All right. So that's the very first thing we want to do is we rewrite this as log base 2 of an x squared minus 5 times the 9, close the parentheses, is equivalent to log base 2 of 19. Okay, so I need to distribute this 9, so this makes log base 2 of 9x squared minus 45 is equal to log base 2 of 19. All right. And now what we're going to do is we're going to exponentiate. And since they're both log base 2s, we're going to exponentiate using base 2. So 2 raised to the log base 2 of 9x squared minus the 45 is equals down the same level as the 2. 2 raised to the log base 2 of 19. These are going to undo each other, and you're left with 9x squared minus 45 is equal to 2 raised to the log base 2. Those are going to undo each other. We're going to be left with 19. Okay. Now, I want to talk about two different approaches we could take to this. Okay, so this is a quadratic equation. All right. And there's two approaches we could take. All right. One is, since I only have x squared, I could get the x squared by itself and then use square roots to solve it. That's one possible way. And that's the way I'm going to do this one. But I want to make it really clear there's an alternative way of doing this. You could subtract 19, okay? And negative 45 minus 19 turns out to be minus 64. So we'd have 9x squared minus 64. Both of those are perfect squares. And then you could factor this using difference of squares and solve it that way. Whether you use square roots to solve it or solve it by factoring using difference of squares, you will wind up with the same answer, okay? A lot of the homework problems, you're going to use square roots to solve it, so I want to go through and do it that way, okay? That's the only reason, okay? So it's really what you see. If this had not been a perfect square, we would have to use square roots, okay? All right? So what I want to do is, for the next, to solve this one, all right, is I want to add 45 to both sides, okay? So that would give me 9x squared is equal to, and if I add 45 to 19, that would give me 64. And then I'm going to divide both sides by 9, and that would give me x squared is equal to 64 ninths. Okay. And then the next thing I want to do is I want to square root both sides. So I want to square root x squared. As long as I square root 64 over 9. I'm going to slide this up a little bit. The square root of x squared becomes the absolute value of x is equal to, and the square root of 64/9. So when you square root a fraction, you can square root the numerator over the square root of the denominator. So this would be 8 over 3. Okay, so the only way for this x, if you take the absolute value, what could this be to give you positive 8/3? Well, this x could be either 8/3 or it could be negative 8/3, right? So x is equal to negative 8/3 or x is equal to positive 8/3. Okay, you could also write plus or minus 8/3 and you'd be perfectly valid writing it that way also, okay? All right, so I'm gonna go back up and then we gotta check both these, okay? So these two solve this quadratic equation right here, okay? But do they solve the original problem? So we got to check and make sure they do. All right. So I'm back up here. We're going to check x is equal to negative 8/3. Okay, so we have log base 2 of, and we're going to have to square negative 8/3. And then minus 5. And then plus log base 2 of 9. Does that equal log base 2 of 19? So I got to get this side to be log base 2 of 19, okay? So if I square negative 8/3, okay, that would give me 64/9. So this is log base 2 of 64/9 minus 5 plus log base 2 of 9. Does that equal log base 2 of 19? Okay, so couple things you could do. I'm going to do it this way, okay? I can take, since these two are logarithms with the same base and I'm adding, I can multiply this with a 9. And here's why I'm going to do that instead of getting a common denominator. I noticed that, hey, if I multiply this, I'm going to clear out this denominator over here. So this becomes log base 2 of 64 over 9 minus 5. And I'm going to put parentheses around that, and I'm going to multiply that by the 9. Does that equal log base 2 of 19? Okay, so when I distribute this, I get 64 minus 45. So this would be log base 2 of 64 minus 45 equals log base 2 of 19. And then you don't have to put the question mark, I just like to. So then this would be log base 2. 64 minus 45 is 19, is equal to log base 2 of 19. That's a true statement, okay? So that means x equals negative 8/3 is one of our answers. So this x equals negative 8/3 is one of our answers. Okay, we're going to need to check the other one. And check x equals 8/3. And so we have log base 2 of 8/3 squared minus 5 plus log base 2 of 9. Does that equal log base 2 of 19? So this is log base 2 of 64/9 minus 5. And this looks a lot like this, right? Plus log base 2 of 9 is equal to log base 2 of 19, question mark, okay? So right now we have the same as this line right here, right? Okay, that I'm pointing to with my pen, okay? So if we were to multiply these, right, we would get log base 2 of 64 minus 45. And this would come out to be log base 2 of 19 is equal to log base 2 of 19. I just put the parentheses in, okay? You wouldn't have to. Let me slide that up so you can see it, okay? Log base 2 of 19 is equal to log base 2 of 19. Okay, so what does that mean? This problem actually has two answers, and here they are, right? So both of these are answers. Okay, so that's solving more exponential and logarithm equations. I'm gonna grab the assignment sheet just so that helps me keep track of what we've done and what we've covered so far. Okay, so I'll be back with the assignment sheet. All right, so for the assignment sheet that we have, I assigned worksheet ELF 6. Okay, so I'm gonna assign that on 3/25. So that's just the date we recorded it. Okay, I'm going to send out the assignment today, which is also March 25th, and I'll send that out on Google Classroom. Okay, all right. You guys have a wonderful day. Thanks for hanging out with me for a few minutes, or maybe close to an hour, possibly. I don't know how long this whole video is yet. Okay, just take care, and I look forward to seeing you guys once school starts up again. Okay, take care.